How's it going? My name's Dim, and in this episode, I'll be taking advantage of Amazon S3 to store all user uploaded files on Amazon servers. With this, we'll be taking advantage of the size of Amazon servers to guarantee customers practically unlimited data uploading. In its current state, our app is storing everything locally, meaning that we are heavily restricted by our disk space. By switching to Amazon S3, we may end up paying more for our disk space, but we will almost never have to worry about our server's disk size. I've forgotten to update the diagram this time. All you need to know is that now our post/files endpoint will be uploading the file to S3, and our get/file/id endpoint will be retrieving the files from S3. With all that said, let's dive straight into it. Well, not quite yet. I made a post about the first episode of this series on Reddit, and a user left the following comment: "Please cover all topics such as authentication, cross-site protection, cookies, etc." Reading this, at first I thought, hey, I already prevent any cross-site vulnerabilities by sanitizing the content disposition file name header. Then the most obvious thing occurred to me. Users are uploading files to this service, and we are just serving them, regardless of the file's content type or file content. Could it be possible that a user can upload an HTML file with some JavaScript, send that file to another user, and get that user's access token? I couldn't see why not, so I wrote a proof of concept. Here we have xss.html, a file that imports Firebase, initializes an app with our public Firebase credentials, and gets the auth service from the app. When the auth state changes, we check if there is a user access token, and if there is, we send it to a different domain by appending a style sheet to the page head. Here we use example.org, but an attacker would send the credentials to their own domain for collection. Let's go ahead and upload this file to our app. We uploaded it and opened it. We can see that Chrome is rendering the page as an HTML file, which means our JavaScript is probably getting executed. Refreshing the page and monitoring our network traffic, we see that our user's JWT is in one of the requests. The server has responded with an error 500, which means that the request is getting through, and if an attacker properly set this up, they could collect the user's credentials. I had a couple ideas in mind for resolving this, namely detecting the content type and changing text/HTML to text/plain. However, I was concerned that text/HTML might not be the only content type that triggers the browser to render HTML. Instead, I searched a bit further and was reminded of the content security policy header. This header lets you control what locations a browser may load certain media like JavaScript, CSS, and images from. The CSP header also has a default -src option to define a default media source for all types of media. In this case, let's do a default src none to ensure that the browser does not attempt to load any kind of media, including JavaScript. With this header set, let's restart our server and see if our xss.html file still does bad things. Refreshing the page, we see that no other network events are fired off after the file request. Going to our console, we get the error message, refuse to execute inline script because it violates the following CSP directive. This is exactly what we wanted, and this should prevent all XSS attacks on our app. With that out of the way, let's try and get Amazon S3 working with our app. Just going to warn you, there will be a lot of referencing the documentation after this point. Amazon services can get very complicated, and you always want to reference the documentation to make sure you're on the right path. For starters, we're going to be storing some very secret credentials from Amazon, so let's store that somewhere outside of our code so that we can still commit our code to a public repository while remaining secure. Your AWS account must be linked to a credit card and is only free up to a certain number of requests and a certain amount of space. If someone were to get a hold of our credentials, they could upload as many files as they would like, while we would be the ones paying for all those requests. To do this, I want to use a package called go.env. This package reads environment variables from a file called .env and sets them in your Go process. The benefit of doing this over manually setting those environment variables in your terminal is that these variables are local to the project and always exist in the folder, so you don't have to write them over and over again. After we run the go get command from the readme, we may copy the code for loading variables from our .env file. Since we're starting to use the .env file, let's go ahead and use os.getEnv to get the environment variables for signing into Postgres. In all honesty, we should have done this several episodes ago to prevent writing a potentially sensitive password in our code. Oh well, now we're doing it. For os.getEnv, we just have to set the name of the environment variable we are searching. In our case, that's Postgres_username and Postgres_password. Let's finally create that .env file and move our constants to it. In .n files, the format is very plain. You just have key equals value on its individual line with no quotation marks. Side note, make sure to include .env in your .getignore file like we did with private_keys.json. It's very important that you don't upload .env to a public Git repository. Now let's get Amazon S3 working with our Go code. To do this, we will search up Go AWS SDK setting up. We come across this guide for setting up the AWS SDK for Go. First, let's copy and run the go get command and install the SDK. Let's go over to Amazon S3. You may find it in the Services tab or from the search bar. Let's click Create Bucket. An S3 bucket is a container for your files, sort of like a system folder. Let's choose our bucket name, ensuring that it's in accordance with the bucket naming rules. I enable ACLs here, but it isn't really necessary. Make sure to uncheck Block All Public Access. This step is necessary if you want users to view the file using the S3 link later on. Now let's hit Create Bucket. With that done, let's create an IAM user and grant the user permission to upload files through the S3 bucket. The reason we do this is because by default, the only one that can upload files is the root user who is signed in through the console. We want to be able to programmatically upload our files using the AWS SDK. So we will authenticate with the API using the IAM user. From the IAM dashboard, let's click on Users, click on Create Users, give the user a name, and hit Next. We want to attach policies to the user directly, so we can choose that option. Let's search S3 and grant the user Amazon S3 full access. Let's hit Next and Create User. Now that we have this user, let's start filling out our environment variables. The AWS SDK uses some environment variables by default, which can be found on the developer guide. First off, we have to set AWS_region to the region we created the bucket in. Scrolling further down, we see that we can set AWS Access Key ID and AWS Secret Access Key to sign requests to AWS. To find our Access Key ID, we have to navigate to the user we just created. Go to the Security Credentials lab and create an access key. Here, let's select Local Code, check the confirmation box, and hit Next. You may write a description, but I leave it empty, and hit Create Access Key. With that done, we can see our newly created access key and copy it to our .env file. Let's do the same thing for our secret access key. Copying the environment variable name, let's show the secret access key and copy that to our .env file. We have a lot going on in our main function, so let's just add some comments for what each block is doing. Now let's copy over the code from our session documentation for AWS SDK. Here we are going to create a new session. We don't have to pass any arguments to the new session since we defined everything in the environment variables. Let's go over to the AWS SDK for S3 documentation so that we can start uploading files. Over there, I noticed this neat session.must utility function, so I just updated my code a bit. Let's also copy this line for creating the uploader. Let's copy these last lines for uploading a file and use them in our post/files handler function. We can replace all this io.copy code with our copied code from the documentation. Let's just change a couple things. First off, we have to specify the bucket to which we are uploading. Instead of hard-coding the value, I'll include it in our .env file and refer to it by using os.getEnv on AWS_bucket. For the key, we are going to pass in our UUID that we created after converting it to a string, then an AWS string. Let's also just get rid of these couple lines since we're not creating a local file anymore. Let's change the error handling here to use context.abort with error. For the body, let's pass in our user file variable. Let's also copy this print statement from the docs and try uploading a file. Attempting to upload our small dog results in an error 500. AWS is saying that we have provided the incorrect region. I copied this directly from the docs and forgot to notice that our region is east and not west, so let's update that. Let's restart our server and see what happens. Well, the request appears to be successful, and when we click on the file, we get nothing since we are still trying to load it from our local disk. Let's try opening the URL from our console. Well, we get access denied since we haven't granted anonymous visitors permission to see our objects. Anyway, let's just try modifying our /files/id endpoint. Let's actually retrieve the file from Amazon rather than trying to get it locally. First, we have to create a downloader. To do this, we copy this line from the documentation. Heading over to our get/file/id handler function, let's copy the lines for downloading the file. We have to pass in a writer as the first parameter, so let's pass in the requests writer. Well, that doesn't seem to work. We need an io.writerat, not just an io.writer. And let's just come back to that in a bit. For our bucket field, we need the same thing we wrote for the other bucket field in our upload call. Since we would have to call this os.getEnv twice, let's just define a variable for the bucket. For the key, let's use field.id.string and convert that to an AWS string. Let's modify this error checker to use context.abort with error. Back to this io.writerat error. I'm not sure what to do about this at this point. I tried checking if the downloader has a method that takes just an io.writer. I didn't see one, so I tried seeing if Jin has some sort of io.writerat that we can access. I couldn't find anything, so I decided to Google make writer into writerat. The solution the user was proposing made sense, but it didn't really fit my case. User uploaded files may be several gigabytes large, so allocating a slice of several gigabytes is just impractical. I saw the solution that said faking AWS writerat with an io.writer, which would have worked but did not seem like a clean solution. After scouring some threads in the AWS documentation, that's when it occurred to me. Why are we using a downloader? The downloader exists to download an object in parallel using multiple threads. That's why a writerat is needed. If we just download the data using one thread, we can use a writer instead. Instead of using a downloader, we can just use the getObject method. To get access to the getObject method, we need to create an S3 client, which we can do by using our existing session. With this S3 client, let's call getObject and use the same options as before. We just need to remove the writer from the parameters. Although we were using io.copy before, I've since discovered that Jin has a method called data_from_reader that lets us pass in a reader and copies that reader to the response writer for us. It does have a lot more parameters. First, we have the status, which we will set to OK, the content length, which we will get from the S3 output content length, the content type, which we have on hand, the reader, which is our output.body, and finally any extra headers, which we may set to nil for now. Finally, let's restart our server and try opening the file. Surprisingly, on our first try, we get the file. Let's try uploading another one just to see, and that one works as well. Let's just quickly remove the header calls that we have and write those headers in the extra headers parameter using a map. To do that, we create a map of strings and separate the header key with a colon. Here, I noticed that we may also pass the content type and content disposition to the S3 object, so I went ahead and did this. You may want to do the same, and you'll find out why we're doing it in just a second. You see, I could have ended the video at this point, but one last thing I wanted to do is make our file accessible directly via the Amazon S3 object link. The reason why I want to do this is that by having Amazon serve the file rather than using our server as a proxy, we are reducing a whole lot of potential server traffic. First off, let's add a location field to our file structs for storing the S3 URL. Let's pass the proxy into that field in our post method. Let's go to our index.js file and instead of linking to the Let's go to our index.js file and instead of linking the user to /file/file.id, link them to file.location. Let's uncomment that drop table line so our database creates the table with our new column. Restarting our app and uploading a file, for some reason the link goes to /undefined. This is not what we want, so let's see what we did wrong. While our JS looks fine, we are just accessing file.location. Let's check our file struct. And I accidentally made the JSON field name string for some reason. Let's change that to location and try again. We upload our file and now our anchor tag is pointing to the actual URL. Attempting to open the URL, we get access denied just like we did before. We have to do something with our buckets policy. Let's go back to our S3 console and go to the bucket we created. Let's go to the permissions tab and edit the bucket policy. Let's click add a new statement and search for S3. After clicking S3, let's look for the getObject action. Let's click on add a resource. Under resource type, let's select object. Replace the bucket name with the name of the bucket. Replace the object name with an asterisk so that the policy applies to all the objects in the bucket. Attempting to save changes results in an error. Missing required field principal cannot be empty. I just quickly Googled this, and it seems like we want to use the asterisk in our principal field, since this policy applies to all users. With this done, we can successfully save our changes. Let's upload our file and try to access it. And it works like a charm. We even have the content type and content disposition headers set like we wanted them to be. We don't have to worry about the content security policy since the file is being hosted on a different domain. As long as we have cores properly configured on our domain, we should be safe. One final thing we have left to do is delete the object from our bucket whenever it is deleted by a user. To do this, let's head over to our delete logic and restructure it a bit. I am sending the status no content before deleting the file from S3 so that the user can get a response from the server sooner. We can copy our call to get object, and instead of changing it to delete object, let's also change get object input and delete object input and set output to an underscore since we won't be needing that variable. Since I don't want to send the error to the user at this point, let's just log it in the console. Let's test it out. Deleting seems to work just fine, because when we delete the file on the website is also deleted from the bucket. Let's try to force S3 to error. I'm going to upload a file, delete the file from the S3 console, then delete the file from my website. This will make delete object attempt to delete an object that does not exist. Well, after doing all that, I don't seem to get any error. Is my logging broken? Well, after a quick Google search, it would appear that delete object is designed not to error when the object doesn't exist. That's a bit of strange behavior, but is also in line with system calls like unlink, so it makes some sense. I'm pretty sure the error logging works though. Well then, it seems we've covered a lot of ground here. We delved into preventing XSS attacks, S3 buckets, IAM users, storing private keys securely, and S3 bucket policies. Since we moved our file storage from local to the cloud, we have virtually unlimited storage thanks to the size of Amazon servers and their pay-as-you-go model. We've reduced a whole lot of network traffic by sending users directly to the AWS link rather than downloading and transmitting the files on our server. I can confidently say that our website is running a server with relatively small computing power that can handle a ton of requests. Anyways, that will be it for this episode. I hope you've enjoyed and hope this inspires you to explore more of Amazon's web services and the elasticity that they can bring to your app. In the next episode, I'd like to get our apps working in a container and run it on my server so that it's up 24/7. Thank you for watching, and until then, stay tuned and peace out.